Hi, and welcome to TEMEKO. In this video, we will recall what is meant by the work of a force, which you may have heard of during your earlier studies or work life. Let's get started. So what is the definition of the work that a force is doing, for instance, for some particle? Well, we can say that a force is doing some kind of work if the particle is moving by some amount towards the direction of the force. Think about the following scenario, in which the particle is moving along the path S from the position R to the new position R' because of the applied force F. Because the applied force causes the particle to change its position, it will have a displacement dr, which also represents the differential segment ds along the path. Now, if angle theta is the angle between force vector and the displacement vector, we can express the work of the force as a mathematical scalar equation as follows. du equals F times ds times cos theta. The unit in SI system which we commonly use for the work is called a joule. On the other hand, because of the relation between a force and displacement, we could also use a unit of Newton meter for the work. Now, if the particle would move along a straight path, and the force which causes the particle to move remains constant while acting as a constant angle theta, we could also solve the magnitude of the work from the following equation. U1 to 2 equals Fc times S2 minus S1 times cos theta. Keep in mind, however, that in the situation where the particle would be moving along another type of path other than the straight path, while the magnitude of the force would also be varying, we would be compelled to use integration to solve the magnitude of the work. Therefore, in this situation, we would express the work mathematically as follows. U1 to 2 equals integration from S1 to S2 of F times cos theta times ds. Notice how in both situations we could also solve the magnitude of the work from the shown areas. As we know, all the objects are subjected to the gravity force by some amount that is related to their mass. Thus, if we would like to lift an object, we would have to do some work against the gravity force. This work against gravity can be written as follows. U1 to 2 equals minus W times delta Y, where W is the weight and delta Y is the vertical displacement of the lifted object. Note that because we are doing work against the gravity force which is related to the weight of the object, our work done is negative by nature. Likewise, the work would be positive if the object were falling. You may also not have thought about this aspect of the work earlier, but while we are compressing or stretching a spring, we are doing work to do it. Consider this. If you are compressing or stretching a spring from its initial position S1 to position S2 by the force F, it feels like the resistance of the spring increases during the procedure. Thus, compressing or stretching the spring gets harder. What could be the reason for this? Well, the main reason why the resistance of the spring increases is because of the spring property called spring coefficient K that dictates how much force we need to use to displace the spring by a certain amount. Therefore, the magnitude of the work that we are doing to compress or stretch the spring can be written as follows. U1 to 2 equals integration from S1 to S2 of Fs times ds, which equals integration from S1 to S2 of K times S times ds, which equals to half K times S2 squared minus half K times S1 squared. We can also determine this force from the following trapezoid area, which is defined by the position borders S1 and S2. As you can see, the spring force increases linearly when the spring is compressed or stretched closer to the position S2. Hopefully, after watching this video, you have recalled what is meant by the work of a force. In the next video, we are going to familiarize ourselves with the principle of work and energy so that you know how to apply this principle for different work-related problems. Thanks for watching and have a nice day.